Good afternoon to everybody once again. So we are going to start the second session of today's session. So the second session will be Ansari sir. So I take this privilege to introduce him first. Mr. M.M. Ansari sir is presently working as assistant professor in electrical engineering department. He has completed his master's in electrical engineering with a specialization of electrical power system. He has total teaching experience of 20 years and total industrial experience of 3 years. He has worked as ex-chairman, Board of Studies of Electrical Engineering, Faculty of Engineering in KBC NMU. He is a member of CDC committee of SSBT College of Engineering and Technology and also working as a LMC of this college. He has received AICT grant of rupees 5.35 lakhs under MODROP. He has published papers in reputed international journals and various international conferences. He has published few articles and many papers. One of the article is in Urdu, whose information is like he has published the article in Urdu on science and technology in National Journal Science Ki Duniya, which is of National Institute of Science, Communication and Information Resources, New Delhi. Recently, he published a paper in journal Science Ki Duniya named as Shamshi Tawanai Ka Behtareen Masroof, that is best application of solar energy. Presently, he is executing the installation of 200 kilowatt PV solar on-grid rooftop power plant and additionally 100 kilowatt power plant in college campus. So I request Mr. M.M. Ansari sir to please continue the session.
Beginning. Yes, good afternoon to all. Thank you, Dhanesh sir. So today's topic is on-grid PV solar rooftop power plant installation and assessment. So the content of this topic comprises of some points, that is the permission and approval from government agencies, this including the state government as well as MSDCL in Maharashtra, selection of PV panels and inverters, installation of rooftop power plant, analysis of bill, performance of plant, and last is the investment and payback. So it comprises of 3 stages before installation and analysis one. The first stage is the site survey and shadow analysis, where we are going to install the power plant. Energy consumption detail and pattern. This is very important to by selecting the capacity of plant, because it is depend upon the type of industry and type of institute. For the industry, the consumption or the power demand is remain constant entirely if it is going to run 24 hours, whereas if it is a educational institute, definitely the consumption is more, and if the institute having some hostels facilities and staff quarters are there, definitely some of the energy is going to utilize in the night time. So therefore the energy consumption pattern is very much necessary to understand. Second stage is the online application to MSDCL. I am talking about in Maharashtra because my college, that is nothing but the SSBT College of Engineering and Technology. So I am considering the MSDCL procedure, but no doubt this procedure is somewhat same in all the state because it follow the grid protocols as well as the safety points. The safety, it is not only for the human being, it is also for the electrical assets are there. Technical feasibility and permission. This is technical feasibility and permission also granted from the MSDCL and state government departments. Third stage is the plant installation and testing. In plant installation and testing, the next point is the testing of CT/PT whenever it is needed to replace it, because whatever the CTs and PTs, current transformer and potential transformer has been installed, they have accuracy of 1, and for the solar plant, the accuracy is needed as per the norm is a 0.5 S or 0.2 S as per the capacity of the power plant, solar power plant, and final release or later from MSDCL or any other type of state electricity board. So in the first case, this is the annexure 1. It has a 3 annexures. So annexure 1 define the what is the procedure of connecting solar power plant, how to get permission from the state government and MSDCL as per the grid norms as well as the safety point of view. So pre-installation, it again we will consider the 3 points. First is the application, means we have to fill up the application form to apply online to apply for the net meterings are there. Second is the technical feasibility and is the single line diagram. So application, it is a online procedure is there, and the portal of MSDCL we have to apply application for connecting a solar power plant, on grid solar power plant to the grid systems under the net metering arrangement. Second is the technical feasibility. This technical feasibility is has to be get from the MSDCL concerned department or concerned head where you are going to install the power plant, and permission is granted from the MSDCL. So technical feasibility consists of capacity of the transformer. If you have own transformer, then the capacity of transformer should be enough. Second is that the maximum power that can be installed, PV power can be installed, which is should be equal to or less than the contract demand of any consumer. For example, the college has a 300 kVA maximum demand, then we can get the permission or feasibility only less than 300. It is maximum of 300 or less than 300 kVA. Then if everything is okay, the feasibilities are found okay, then the permission is granted from MSDCL. In the stimulated period into the 6 month or 3 month they are give, and in that period we have to connect the plant or we have to take the final release letter from MSDCL. Now single line diagram, it shows the where you are going to connect the solar power, where you are going to inject the power. So it is necessary to draw the single line diagram. If the capacity is more than 200 kilowatt, then we have to take the permission from chief electrical engineer, electrical inspector wings from the region or from the district. Otherwise, if the plant capacity is less than 200 kilowatt, then your concerned circle office, that is called as a superintending office in Maharashtra, in every district, he or she is going to grant the permission. So this is something which is related to pre-installation activity involved in the solar power installation of solar power plant. Now it indicates the nodal offices and at particular level of kilowatt connection from where we have to take the permission. If your single phase unit is there, less than 8 kilowatt power plant is there, so subdivisional office has a concerned has a authorized authority to give the permission. If your plant is up to the 150 kilowatt but it is connected to the low voltage low tension side, then again your concerned subdivisional office is authorized that plant or it will give the permission. Whereas if you have a 11 kV feeders, that is you have a HT consumer either 11 kV or more than 11 kV, then we have to take the permission from circle office, that is the superintendent engineer of MSDCL. So these are the nodal officers are there where we can get the permission depend upon the capacity and depend upon the voltage levels of the consumer. Now annexure 2 define the simple, it is the application forms are there, and first which we have already first of all we have to apply on the online, and from online we have to pay the fees. Nowadays the fees is something 5,000 rupees, and once the ID is get generated, you have to fill that application form with the help of some ID number. So it consists of a general information, and in general information we have to submit all the data. Only we have to carefully fill up that capacity of the existing system, that is what is your sanction load and sanction demand is there. So college has presently has 752 connected load is there, and whereas the contract demand is 300 kVA. So when the contract demand is 300 kVA, we cannot connect more than 300 kVA capacity of PV power plants. Either we have to enhance the capacity of transformer, or either we have to go for the enhancement of maximum demand. Once your maximum demand get enhanced with the permission of MSDCL, then and then you are entitled to connect a higher capacity power plant to the grid system. So what is the voltage level? What is the capacity of power plant? It is get included in the annexure 2. Now post installations, once the installation is completed, you have get the first permission from the MSDCL. Now we will go for the post. So what is that post installation stages are there? Plant testing. Once you have connected inverters and ACDBs, DCDBs and earthings are there, we are going to conduct some small tests are there, but no, we have to take care that we cannot inject the power in the system because we have not got the release later. So it is only the in plant testings are there, plant installation with the period of validation, whatever that collect the technical specification testing reports received from the manufacturer. It is the test report from the PV modules are there, inverters are there, then lightning arresters and all the testings reports. If you submit to the MSDCL, they will grant the permission, or they will release they will send a letter that is called as a release letter in Maharashtra. So MSDCL shall complete the testing of net meters. If the net meter is new, we have to conduct the test, and we have to collect the certificate from MSDCL as well as the manufacturer. If the CTPT replacement is needed, as already discussed, that in case of the old our cubical meters, the we can say that the capacity or as well as the accuracy is somewhat smaller. So we have to increase the accuracy of the CTPT, that is a 0.5 S and 0.2 S as per the norms laid by the MSDCL. And second, earlier CT has a burden is up to the 50 VA. Now the new CTs has norms of the 20 VA burdens is necessary for connecting the net metering system. Now, if everything is okay, the eligible consumer and MSDCL will enter into the net metering connection agreement. It is that this agreement between the customer as well as customer and distribution licensee. So in Maharashtra, the distribution licensee is a MSDCL. In other state where it may be some other department or state boards are there. If after this one, a final power release letter is going to sanction from MSDCL, and we can synchronize the plant, our on-grid power plant, to the grid system. So this is the stages in the pre-installation and post-installation. So this is the simple copy net metering connection agreement, and this agreement on the stamp paper between the consumer as well as a consumer and distribution licensee is there. Now next stage is the selection of PV models. So the selection of PV models depend upon the area available over the rooftop. If you select the PV model of the smaller capacity, definitely it requires more space for the installation. Earlier we have only 250 watt PV models are there, but nowadays 400, even more 450 PV models are available in the market. So the things I am going to discuss is the 100 kilowatt solar power plant which we have already installed. The next phase we have already connected is a 95. So existing power plant in my college is 195 kilowatt is connected under the net metering scheme. Whereas 100 kilowatt is going to install, the work is in the progress. So this is one modules where we have installed the 315 uh, watt solar modules are there. So in the solar modules, we have to keep what is the maximum power generation, what is the open circuit voltage, short circuit currents, and very most important is the what is the STC. So STC is nothing but the 25 degree centigrade. At 25 degree centigrade, all these parameters are there. But as well as soon as the temperature of the system, temperature of the atmosphere is gone increasing, the maximum power output and voltage get decreases. So we can say that the very much concerned with the geographical condition as well as the temperature effect over the performance of the PV modules. Now, this is something which is a IV character curve for with radiation with respect to the radiations. This is voltage, and there is a different radiations levels are there, and this will shows the temperature effect at 25 degree. The temperature, this is the voltage and current IV characteristic, but as soon as the temperature increases, we found that it is get shifted to the left side. So now see, this is the new panels which we are going to install in the 100 kilowatt additional power plant, that is a phase 3 power plant is there, and it is the mono type per half cell technology is there. It has a maximum power where we have selected the 405 watt power is there. So it has two categories, two columns are there. One is the STC and second is the NOCT. STC is the standard temperature condition is there, and it is the normal temperature, whatever the temperature, because in Maharashtra the temperature is not 25 degree, it is always higher one, and in the summer season again it reaches to the 42 degrees are there. So what would be the maximum power is there? Okay, so here it is 405, it's the rated capacity, whereas at NOCT it is 306. Here the power get decreases because of increase in temperature. Now second is the maximum voltage is 42 volt, whereas the in NOCT it is a 39.8 volt, or it may be a 39. It's a somewhat rated one again. Now very much it is important is that the model efficiency at STC is 20%, and temperature coefficient of maximum power is minus 0.35% per degree centigrade. So while selecting the PV model, we have to check what is the temperature coefficient. If the temperature coefficient is higher, it means that because of increase in temperature, the power decreases drastically. For example, suppose the temperature coefficient is 1 instead of 0.35 minus 0.35, it is 1. So every 1 degree, the efficiency get decreases by the 1%. So if the temperature coefficient of maximum power is minus 0.35, or it is less than 0.35, or it is a 0.25, it is attraction for the purchase, or that we have to select the PV model with a small value of temperature coefficient. Now similarly, it is also depend upon the temperature, also depend upon voltage is there. So voltage coefficient, temperature coefficient is minus 0.29. So as soon as the voltage, as soon as the temperature increases, atmospheric temperature increases, the output voltage get decreases. So it is quite obvious, quite clear from this table. At STC it is 405 watt, 405 watt, whereas at NOCT it is 306 watt. Similarly, the maximum power voltage, it is 42 volt, whereas NOCT it is 39 volt. It is quite clear from this diagram. At 25 degree, this is at 25 degree, the power, the maximum power and maximum voltage is there. But as soon as the temperature increases, say 50 degree or 75 degree, the power, maximum power get decreases. At the same time, voltage also decreases, whereas the current somewhat increases. So this is the change in temperature. This is the change in parameter with respect to the change in temperatures. Now, grid-tied inverters. So while selecting the grid-tied inverters, there is some parameters to be observed. So what is the maximum power DC can be connected, and what is the rated power output? So we will find here the maximum DC power is 62.5 kilowatt, whereas the rated output power is a 50 kVA. So this output power is the AC one, whereas the input power is a DC. So to get the proper voltage and proper output power, it is necessary to connect the number of modules in such a way that the maximum input should be there, or we can say that up to 90% DC should be connected in the primary in the input side. So you may connect 55 kilowatt DC PV modules are there, then it will get the proper output. This one maximum voltage is 100 volt 1000 volt is there. It means that while designing the strings, number of PV modules, those are connected in series in such a way that its voltage should not increase more than 1000 volt, and similarly the voltage should not decrease at minimum voltage, that is a 520 volt. So the number of modules, those are connected in series in such a way that their total voltage, series voltage, should not be less than 520 volt, and it should not be more than 1000 volt. Then and then it will give the proper voltage in the input side, and we will get the voltage in the output side. No doubt the output side voltage will be there at that particular value. So nominal DC voltage is the 600 volt. Maximum DC current is a 50 ampere. So while connecting the number of PV modules are there, again we have to calculate what is the maximum current, and the maximum current should not be a more than 50 ampere. Now one more points to be considered here. Disconnecting switch should be there, and built-in energy data loggers are there, which will give the energy generation by that particular inverters in a day, in a week, or say in the month or yearly. So in all type of inverters, this type of facilities are there. What is the maximum efficiency, average power factor, and all these things. And one more important factor is anti-islanding switch or protection is there. It is indication is yes, or flag is yes. What it means? It means that suppose it is a three-phase inverters, by some accident or by some way, one of the phase out of service, your inverter should be switched off. Otherwise, it may lead to the accident. The person who is working in the distribution section or in the distribution area is there, because it is connected, it is directly connected to the transformer, and if your inverter supplying some power, it is remain on, two phase remain on, it will give the an HT side, it will develop a high voltage, or the person or the team, those are working in maintenance, they may it may lead to the accidents. Now this is the single line diagram for the 100 kilowatt. This is we will start from the our inverter side. So this is the PV arrays or strings are there, number of strings are there, 19 strings are there. It is connected to the input of inverters. There are three inverters, 50 kVA, 20 kVA and 30 kVA. So total is 100 kilowatt solar plant is there. So this is the DC side. From this AC side, this is the AC cable is there. It is always a copper cable, 3.5 core or 4 core cables are there. It is connected to the ACDB. So here the some DCDBs are there, and it is now from the output side of the inverter, it is connected to the ACDB. Now where to install the ACDB? It is recommended that the ACDB should be installed on the rooftop. It will become it will help during the maintenance time. So it indicates that the person who is working anywhere in the inverters, he are confirmed that the switch is off, and nobody is going to switch on in his or in her absence are there. So it is recommended that the ACDB should be installed near to the power plant, or it should be at the rooftop of the system, rooftop of the area is there. Okay, so it consists of number of feeders are there, and one more circuit breakers as per the capacity. Some data loggers are there, and it is connected to the our generation meters are there. So this is also the AC cable. It is a aluminum cable. It is connected to the generation panel, and in generation panel with CT and CTs are there, and generation meter are there. Again, this is in the custody of MSDCL because they are going to verify the power measured by net meters as well as the generation meters are there. And from this generation meter, it is connected to the main distribution panel. And while connecting to the main distribution panel, it should be ensured that the DG set power should not be connected to the PV models. In Maharashtra, only we can connect the PV module with the grid. Say MSDCL grid is there. It is not allowed here to connect your PV models or a PV solar plant with your generator systems. So whatever the changeover switch is there, it should be ensured that during generation of DG set generation operation, our PV model should be disconnected. Now this is the single line diagram for 300 kVA power plant, which because we are going to install over there. So this is our transformer from 11 kV line transformer. CTPT units is there, which is in the custody of MSDCL, and it is connected with the some DO fuses, and OLTC. We have a OLTC transformer, on load tap changing, to maintain the voltage. This is the changeover switch. It is connected to the DG set, and once the grid fail to supply, our power plant also get mute, or it is done. It will not deliver any type of power over there because it is a grid connected one. So now with the help of this changeover switch, the power is going to deliver to the load only by the DG set, and PV plant is disconnected. Now for this one, we have make one generation panel. It consists of extra 2 feeders are there for the future expansions. So it consists of 800 ampere air circuit breakers and islanding switch. One more islanding switch is necessary. This islanding switch, I will show this one. Okay, so I will show one by one. Okay, this islanding switch is necessary to see the physical switch, to see the physical switch under the maintenance work, and it is necessary in MSDCL. Otherwise, MSDCL does not give the permission to connect a solar plant to the grid system. No doubt, in our inverters which we have here, anti-islanding switch is protection. Anti-islanding protection is yes. The flag is yes, even though because it is inbuilt in the inverter, which is not visible. So therefore, it is necessary to put one more islanding switch for the protection point of view in the generation panel. I will show this picture of this islanding switch also. Now material handling, when we purchase the PV models, it is very much necessary to handle very carefully. We have to select a proper capacity of the crane, and at the same time, when we are going to unload it, we should place in the plane surface, otherwise the glass or it may bend or it is going to break. So see here we have placed unloading into the very plane surface to avoid such activity, to avoid such faults in the system. Next is the installation of steel structure. So this is our rooftop system, rooftop area of the building, and this is steel structure is there, and it is a galvanized, hot dip galvanized is there, which will reduce the weight. Otherwise we can use the MS channel, but the MS channel weight is very high and it will increase the weight over the roof. To avoid, it is recommended to use the hot dip galvanized steel structure for installation of PV models. So these PV models are there. One more thing is that it is the standard practice to use the pedestal of the size 400 mm by 400 mm by 400 mm. It's a cube over this to reduce to avoid the kite pressure as a pedestal on the steel structure. But to reduce the weight over the rooftop, we have designed a new civil pedestal in such a way that we can see here the distance between these two beams are around the distance which is equal to these two legs. Alternate legs is there. So we install the plant in such a way that at least one leg should be over the beam. So it will avoid the point load over the roof, over the slab. So this is the entire steel structure has been installed with proper alignment, and it is very much necessary that we have to put some of the PV models before concreting. Otherwise, it will produce the stress over the PV models. So the final alignment is carried out after alternate installation of PV models. And the new things which we have carried out, we have reduced the size of pedestal by 300 by 300 mm, which is earlier 450 mm by 450 mm. It is reduced by 300 mm by 300 mm. Now here the weight of the pedestal get decreases. But to avoid the kite pressure, because of the heavy winds are there, we have used one GI pipe. This is the GI pipe, and it is inserted into the pedestal and it is grounded across the wall. So it will make some grid. It will make a grid, and hence by this method, this is the unique method which we have adopted as compared to the conventional system to reduce the weight over the slab, as well as it will make a grid to avoid the kite pressure. So now see, one module has been installed, just it is mounted to see whether my alignment is correct or not before doing the concreting. Now here alternate module has been installed in such a way that everywhere it can be installed, it can be removed very easily. There is not any such any stresses are there, and once it is confirmed that all modules are easily installed, the meaning is that it is properly aligned, and after that we have to do the concreting. So this is the some people are going to erect alternate modules over the structure, and once it is ready, then we can do the concreting. So MS2 or whatever that concreting proportions are there, we can do the concreting. So this is one concreting has been carried out with the strengthened by GI pipe. The concreting is strengthened to avoid the kite pressure. So now this is the entire one table is ready. This consists of this grout is grouted at the wall side. This pipe is grouted on the both side, so it will avoid the kite pressure because we have decreased the weight of pedestal. So this is the anti kite pressure can be produced with this new method. So this is the second table which is ready, and once the tables are ready, we have to do the DC connection, that is the forming some kind of strings. Either 8 modules are connected in series or 19 modules are connected in series, and this is number of strings also depend upon the type of inverter we are using and what are the facilities are available in the inverters. So this is the tables are ready. Now this is the ACDB. I have already told that the ACDB should be installed on the rooftop areas only, because it become easy for the maintenance and testing purposes. So it is the outdoor type, so definitely it should be a canopy. It is a weatherproof, IP65 is there, and this is the inside by second double door is there. This is the first door and this is the second door is there, and there are 3 inverters are there. It is a 30 kilowatt inverter, 20 kilowatt inverter, and 50 kilowatt inverters. It is connected to the single switch, is a 200 ampere MCCB, and it is connected with the AC supply. Lightning arrestor is very much necessary. So here the lightning arrestor is connected, and the lightning arrestor has a distinct earthing pit two number of distinct earthing pits are there. It is also connected with the counter. If the lightning strokes are going to occur, the counter is going to increase, or the counter will show how many strokes has been occurred during that period. So this is the lightning arrestors are there. This is the earthing electrodes are there. Is a chemical earthing. So we have to do some borewell type excavations, and once the excavations are there, we have to immerse this one. So this is the excavation is carried out with the help of borewell machines are there, and once the borewell is ready up to the 10 or 11 feet, we will immerse electrodes, earthing electrodes inside it to connect the. So there are total 6 earthing pits are there. 2 for ACDB or AC earthings are there. 2 DCDB DC earthings are there, and 2 for the lightning arresters. So here it is a 26 on testing is carried out on to 26 Jan 18. So this is the way we have installed this one. This is our testing. This is our installation team. Now it is the AC panel. So in AC panel, it is a 800 ampere ACB is there. Air circuit breaker are there, because no doubt we have installed first 100 kilowatt plant. Now next plant already installed 195. So existing power plant is 195 kilowatt solar PV on grid power plant is it is in working, and one more third phase is a 100 kilowatt we are going to install, or it is in the process. So because of this expansion, the panel has been designed with 2 existing power plant and 1 for the future expansion. So 800 ampere 800 ampere ACB is there, and islanding switch. So this is the open door is this is 800 ampere ACB, and 800 ampere contactor is there. And in addition to contactor, there is a single phasing preventer are there. Any if suppose DO occurs, means one of the fuse occur in the HT side, because of the single phasing preventer, it is going to open the isolator, this contactor. So once the contactor is open, it will disconnect all the PV modules or inverters automatically, and now it become a visible islanding switch, which is necessary and which is mandatory from MSDCL. Otherwise, even though it is inbuilt in the inverter, but visible islanding is necessary, and it is carried out with the help of 800 ampere contactor in addition to the single phasing preventer to open the contactor even when the single phase when the single phase or under voltage is going to occur. So this is the 2 MCBs are there, 200 MCBs are there, which is connected to the 2 plants, and 1 for the future expansion, and it is the generation energy meter. So this is the view. 800 ampere MCC contactor LNT. It is a single phasing preventers over this one with additional contactor, auxiliary contactor, and everywhere there is a MCBs are there. So one can check by operating this MCB or MSDCL. When they give the permission, testing team is going to perform the test over this islanding with the help of this MCBs are there. So this is the 800 ampere ACB. Now in addition to this one, this is our main panel. This is connected to the one changeover switch, means MSDCL power, grid power from the transformer, one power from the DG set, and whereas this part is isolated with the DG set. In any case, the DG power does not come into this section, and 800 MCCB is connected for the especially for the solar. So now in this case, this is the meter, this is the ammeter which will indicate the solar current. This will show the grid current because it is used in the other slides. So I'm going to explain. These 2 meters are indicating the power taken or current taken from the MSDCL. It will indicate the current or power generation from the solar power plant. So in particular day, I have written the date. It is the 1st of October. My load is 190 ampere, means the college load is 190 ampere, whereas I am getting the current from the grid is only 25 ampere. it means that rest of the current is taken from the solar plant. So 25 ampere is taken from the grid, whereas the load is around 190 ampere. Rest of the current is taken from the solar plant. So therefore, this is such type of meter to be installed over the main panel and the distribution panel, which will easily indicate either my solar plant is working or not, or either some tripping is going to occur. So it is a simple say display, and anyone can understand the plant is working, because in every day we have to check either the plant is working. Since the plant is mounted over the rooftop, there is no sound, there is no indication that the plant is running. Only such type of meters, small meters, say very simple meters, are necessary to check the plant is working or not. Okay. Now this is the again same thing. The solar plant current is around 210 ampere. So the current delivered by solar plant is 200. Load is say it is 190. It means that the current 25 ampere, this current I am not taking from the grid, whereas I am delivering this current to the grid, since the solar current is more than the overload. So rest of the current, nearly 25 current, is going to deliver to the grid system. So it is the export condition of solar plant. Net meter will measure import power, export power. So this situation is the export power. Now to understand the energy bill, this is the MSDCL energy bill. No doubt it is somewhat same with the other distribution licenses are there. It will consist of name of consumer, type of consumers, then contract demand. What is the contract demand? What is the sanction load is there? Type of tariff is there, type of category or electricity duties, and type of consumer, that is based on the LT and HT consumers are there. Now this is the energy bill, total energy bill. Now here the difference of these meter readings, that is the kWh meters and energy meter, is there in the different zone. The difference of these two meter reading is the total consumption in the premises. This is the total consumption, whereas adjustment or solar unit, this much unit has been injected in the system, so it is get minus. So to analyze the electric bill, it is necessary to understand where my solar energy, either it is get subtracted or not in the, so what is the benefit of solar unit or solar power plant in that premises. So here it is only 100 kilowatt solar plant is there in that period. So 1,664 unit is going to injected in a 1 month in the grid. Now what is the different rates are there, different parameters are there. So demand charges, whatever the demand charges are there, wheeling charges is there. Then energy charges, TOD tariff is there, which is applicable for all type of HT consumers. Then electricity duty and power factor penalty and power factor incentive. Only to install the power PV solar power plant does not give the uh, uh, economical benefit, whereas we have to maintain the power factor anyhow. So here the power factor has been maintained. So you can see here the power factor is okay. Here the average power factor is 0.958. So the power factor is very good, appreciable. Therefore, we are getting the benefit of the power factor. It is called as an incentive. It is a something rupees is there for the incentive as a power factor improvement. Now it is the export meter. In the net metering system, there is a we will get the three type of energy bill. One is the export, second is the import, and third is the generation, solar generation. So it will export how much energy has been exported or into the grid. So this is the 1664 means 1664 unit has been transferred to the grid system, which has been already deducted from the main electricity bill. And this is the generation meter readings. So total generation for this month is 11,681 units are there, which has been generated in the month, and out of 1668 is given to the grid system. Now this is the one chart is there, which will show the energy energy consumption and energy generation by the solar plant. In year 17-18, there is a no solar plant is there, whereas in 18-19, 100 kilowatt solar plant has been connected to the grid system. So it is the total consumption in that particular month from April to the March, and whereas the consumption has been decreased in the year 2018-19 because we have installed 100 kilowatt solar power plant. So here the solar generation is there in every month. So in 1 year, around 1.4 lakhs unit has been generated by the solar power plant, and because of this one, it will give some sort of benefit. It is come into the analysis over there. So this is the energy generation in the different month with the help of some figures, some bar chart are there from April to the March. We found that in July and August, because of this rainfall and all this one, energy generation is smaller, whereas in April, May, as well as October, November, the energy generation is very good, appreciable, because the radiation also good, as well as the temperature is appreciably for the solar PV modules. This is the differences in energy consumed or energy taken from MSDCL and energy in the year 2017-18 and 18-19. In 17-18, there is no PV modules and PV plants are there, and whereas in the year 2018-19 we have installed the power plant, solar power plant. So our consumption has been decreases, which is given by the red in color. Every month the consumption or the power taken from MSDCL has been reduces. Now this is some summary report of 195 kilowatt. In 2019, we have connected the second plant into the system, in the existing system, by 95 kilowatt. So the total capacity of power plant is 195 kilowatt. So this is the generation per day generation is there. This is CUF, coefficient of utilization factor. It is 17 to 23. As per MERC, it is accepted from 15 to the 20%, whereas we are having appreciable good CUF, 17 to 23% is there. Specific yield, it is found that it is 4%, 4 unit per day per kilowatt, and in the range of 4 to the 5 is there. It is radiations are there, and inverters, individual inverters, how much energy is generated from the individual inverters are there. No doubt the inverters capacities are different. This is it is 30 kilowatt is there, it is 50 kilowatt, it is again 30 kilowatt is there, and rest of Thea inverters, it is a 30 kVA 30 kilowatt inverters are there. So it is for the 7 days in the month of September, and this is the in the month of March. So we will find somewhat higher energy generation in this period. So the energy generation from by the solar plant is depend upon the geographical condition and seasonal variation, whereas CUF does not include the seasonal variation as well as the geographical conditions. We will see in the last slide this discussion. Now in year 1920, this is our solar plant generation is there, which is connected by 195 kilowatt. So the total generation for the year is 2.1 lakh unit has been generated by the solar plant, where we have maintained the power factor. Only solar plant generation, power generation is not sufficient. In addition to this one, we have to maintain the power factor, then and then it will give the financial benefit with the help of solar PV modules or on-grid power plant is there. So by saving by solar power plant in 1920, it is 25 lakhs, whereas the total amount earned by the solar plant is a 42 lakhs. Now this is the recent data which is available from April 20 to November 20. No doubt because of this pandemic, the consumption is very small. We cannot say that this is the normal consumption of the college. The normal consumption of the college in the range of 60,000 unit to 670,000 unit, depend upon the different month, and temperature variations are there. But it will indicate a very important parameters over there. Here, instead of a kilowatt billing, the new billing method is the kVAH billing, which is implemented April 20. From that same month, it is implemented. So the major part is that this is our solar generation over there. This is the energy consumed or energy taken from the MSDCL, it is in the kilowatt. So it is in kilowatt, whereas the total whereas the billing is carried out over the kVAH bill method. So we can see here 3802 and here 3848 kWh is there because of the power factor is 0.988. Okay, whereas because of the sudden lockdown, some of the capacitor remain connected in the system, and therefore we've observed that our power factor has been decreases from 0.988 to the 0.544. It is in the leading side in the month of May because of the sudden lockdown occur, and nobody in the college premises which will take care of the automatic power factor as well as the fixed capacitors are there. So because of this one only, the consumption is 5,000 units, whereas the billing unit or billing kVA is 9,000. So in the next in the kVAH billing, the power factor maintenance become very important, even though we are having the appreciable capacity of solar plant. So up to after this month, the power factor is maintained now. In the November latest bill is there, and we found that the power factor is 0.992. So there is a small gap between the active energy consumed by consumer or the by college as well as the billing kVH. The difference is not so much. Now here the total till date the power has been generated is nearly 5.4 lakhs unit has been generated from existing solar plant, and which uh, uh, give the revenue of 65 lakhs has been recovered from our solar installation. Whatever the solar installation 90 lakhs are there, out of which 65 lakhs has been recovered in the 2.5 year. This point we will consider in the financial analysis. Now the new billing method is the kVAH billings is there, which is going to which has been implemented from April 2020. So here we can see the in the last this one also, this is the active energy consumed by the consumer, whereas this is the apparent energy consumed by the consumer, and we have to pay the electric bill by this apparent say total energy, that is the true energy from this one. Therefore the electric bill amount is going to increase. So this is the kVH billings over there. In kVH billing, some of the complication has been eliminated over there. Only the demand charges are there, billing charges are there, energy charges which is based on kVAH, electricity duty is there, and now the power factor penalty and excess demand has been here is especially the power factor incentive and power factor penalty has been included in the kVAH billings. So no need to calculate the power factor incentives and power factor penalties are there. No doubt up to this one we have earned around 20 lakhs over the power factor incentives. Now capacity utilization factor, which is already discussed, that the capacity utilization factor is similar to the utilization factor of a thermal power plant or hydropower plant. But in such type of power plant, the power plant is going to run 24 hours. Therefore, the utilization factor is higher one. But in case of the solar system, it is going to run only 7 to 8 hours effectively, and rest of the system rest of the time the power output by the solar plant is zero. So we cannot compare that CUF very accurately. We cannot analyze the plant very accurately only by the capacity utilization factor, because the capacity utilization factor does not consider the dust and dirt accumulated over the PV models. It does not consider the climate condition, that is the temperature variation and geographical conditions, damage of the some of the PV models, or shutdown, or we can say that down period of MSDCL. PV mod, our on-grid power plant is going to run only when the MSDCL or grid voltage is there, grid supply is there. If the grid supply remain off, our power generation again becomes zero. So such type of factors are not included in the CUF. So CUF, only CUF does not show the proper performance of the our solar plant. Now, what is the method to calculate the CUF? CUF is the energy measured in kWh divided by 365 days, multiplied by 24, multiplied by installed capacity. So here is the 24. Even though the plant is not going to run 24 hours, it is going to run effectively 5 or 6 hours only. So therefore, CUF is very small, in the range of 15 to 20%. And it is found that MERE recommended the recommendation value of the CUF is only 15 to 20%. Therefore, so the things which we have, it doesn't consider the degradation of the panel, no doubt, and availability of grid supply. Solar model system, solar PV model does not work at night, so therefore the CUF will be small. To overcome this difficulty, the new parameter is called as a performance ratio, is a useful tool to analyze the PV system. So what is the this one? So performance ratio. The performance ratio is calculated by this formula, that is actual reading of plant or actual energy generated per annum divided by nominal plant output. So formula for the calculation of nominal plant output is the annual solar irradiation at the generation surface of the plant multiplied the relative efficiency of the PV models are there. For example, for if you consider the 1 year analysis is there, so measure the area, what is the area available for the PV models are there. Then generation area of the PV models is a 10 square meter. Efficiency factor of the PV model, it is considered as a 15, and total energy or exported to the grid is 110 for the given data. Now from this one, irradiations are going to calculate 120 kWh per square meter, and here is a 10 square, so it is 1200 kWh is the radiation available, and this is depend upon the every day it is going to calculate it is going to calculate over the um, geographical condition, temperature, and all these things are going to considered over here. And by this way, if you calculate the performance ratio, it is suppose it is in the range of 70 to 80, it indicates that 20%. For example, here we have calculated the performance value is approximately 61%. It means that 39% of incident solar energy is in the analysis period is not converted into the useful form, and this is maybe due to the defect, it may be due to the power failure of the grid, it may be due to the temperature variation. So all these points are going to consult in the performance ratio. Therefore, performance ratio will indicate the proper analysis of PV on-grid power solar plant. Now, this is the financial analysis. It is very quite attractive. Why it is attractive? Because the investment and the payback period is very small. Any investment, if the payback period is very small, definitely it is become very interactive. So I have calculated this one for only 100 kilowatt solar plant. The investment for the 100 kilowatt solar plant is 47 lakhs, whereas the revenue generation per annum means it is 17.1 lakhs. Here the points which is considered for the revenue is that 1.4 lakhs unit has been generated in the first year, multiplied by the energy rate in the electric tariff, whatever the electric tariff is there is a 9.41 is the energy rate per unit. In addition to the energy rate, there's a wheeling charges is there, and electricity duty, that is at 21%, because all the private engineering colleges comes under the commercial establishment. The connection comes under the commercial establishment. Therefore, the electricity duty is 21%. So by adding this all charges over the one unit, the revenue developed or revenue generated by the solar plant in 1 year is 17.1 lakhs. So by this, by calculating the payback period is maximum of 3 year, and it is ranges from 3 to 3.5 year is the payback period, and the estimated life of the project is around 20 to 25 year. So the conclusion is that by installing the power plant, by installing the PV module rooftop power plant, The payback period is quite small as compared to the investment, and hence it is very advantageous. It is the today's need to become independent, and it will energies of the country. So thank you. This is the so if you have any questions.
Yes, participants are requested if they have any query, they can feel free to ask.
Sir, are there any schemes available?
Yes, nowadays scheme is only for the residents only for this 5 year. Whatever the scheme which is available for industry and institutes is not available in Maharashtra. Now this scheme is floated for the residential area only up to the 5 kilowatt.
Thank you, sir.
Hello.
Yes.
Good afternoon, sir.
Good
Sir,
afternoon.
this 47 lakh rupees cost you have showed, is it include subsidy or not?
No subsidy, sir. College has purchased its own without any subsidy.
Okay, sir.
Now it
Thank
is
you.
even it is smaller. Even 42 and 40 lakhs you will find imported panels and delta inverters is available. This is very competitive market are there. New power plant which we have purchased is only in the range of 40 to 42 lakhs per kilowatt per 100 kilowatt.
Okay. Thank you, sir.
Yeah, yes, any other participants have any queries? Thank you, Sham sir, for giving a compliment, sir. In the chat box, Sham sir have written that first time he has seen an earthing system in PPT, and a
Thank
very
you.
nice presentation was given by you.
Thank
Thank
you.
you, Sham sir. As a speaker is unable to see the chat, so on behalf of him, I thanks you, sir, and all who have written the comments in the chat box on behalf of both the speakers. I'm very thankful to all of you. Thank you, sir. Any queries? Okay, thank you, everybody. Thank you, Ansari sir, for giving us a very wonderful and very informative session on the topic of on-grid PV solar rooftop power plant installation. It is very nice to see all the pictures and PPTs. And I thank all the participants for their patience learning, patience listening also. Thank you, everybody. We will meet at afternoon session at 2:15 p.m. for the practical session. So thank you, everybody. Thank you so much.
ऑफ कहाँ से करना है?